2.2 Basic Differentiation Rules and Rates of Change, Day 1. Today we're going to start learning the shortcuts for derivatives. All right? Where it's important to still know that f prime of x is our limit definition as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. It's still important to know that, but we're going to learn some shortcuts to make our life a little bit easier on certain problems. All right? And the shortcuts we're going to learn today are the constant rule, the power rule, the constant multiple rule, and the sum and difference rule. Seems like a lot, but they're pretty easy rules. The first rule is the constant rule. Now remember that derivative stands for slope of the tangent line. Well, if our function is a constant, meaning it kind of looks like that, what's the slope? Well, it's a flat line. Slope of a flat line is 0. So y equals 3, the slope, or the derivative, is 0. F of x equals 14. The slope, or the derivative, f prime of x equals 0. And finally, y equals negative 3/4. The slope, aka the derivative, is 0. So what is the slope of a constant? The slope of a constant is 0. Therefore, the derivative of a constant function is 0. The next rule is the power rule. And I've worked out some examples ahead of time to try and spot a pattern. So we'll start off with f of x equals x squared using our limit definition. Set it up. We square it out. These x squareds will cancel. And then these both have delta x. So one of those factors in cancel. We're left with 2x plus delta x. And delta x approaches 0, so the f prime of x is 2x. Doing the same thing for f of x equals x to the third. We'll set it up and we'll cube it out. I used Pascal's triangle to do that. We got x cubes cancel, because one's positive, one's negative. Delta x is present in all three, so we can factor and cancel. And then delta x approaches 0, so we're left with f prime of x equals 3x squared. For x to the fourth. Again, we'll set it up. We'll take the fourth power and work it through using Pascal's triangle. Negative x to the fourth, it cancels. What's left? Everything has a delta x. So we can factor it and cancel it. And then delta x approaches 0. So this part falls off. And f prime of x equals 4x to the third. So let's look at it all together. If f of x equals x squared, then f prime of x equals 2x. If f of x equals x to the cubed, then f prime of x equals 3x squared. And if f of x equals x to the fourth, then f prime of x equals 4x to the third. What I'd like you to notice is the multiple in each of these and the power in each of the originals. So the multiple in each of them is equal to the power. And what happens to the power as we go to the derivative? All right. Notice the derivative is always 1 power down. So, the pattern. If f of x equals x to the n, then f prime of x equals the power will come out front and then power down. So we got n x to the n minus 1. That is the power rule. The derivative of a monomial, x to the n equals n x to the n minus 1. All right? And then tying that into the constant multiple rule, basically what we do is we take this 3, we kind of hold it there, and we just take the derivative of x squared. Well, the derivative of x squared, the 2 comes out front, 2x, then 2 minus 1 is 1. And then we'll just take that result times the constant. So y prime equals 3 times 2x, which is the same thing as saying 6x. Now this one didn't come out very well. This one's supposed to say 4x to the 5th. So the derivative here will take 4, y prime equals 4, and we'll multiply it by the derivative of x to the 5th. Well, the 5 will come out front, 5 times, and then the power will decrease by 1. So y prime equals 4 times 5x to the 4th, which we can simplify to 20 x to the 4th. Okay, the sum and difference rule, same idea. We got a series of functions added together. We got this function plus this function, or minus that function plus that function. Do each of them separately and combine the results. So the derivative, y prime, the derivative of 3x squared, the 2 comes out front, 6x minus, for the next function, the derivative of 4x. The derivative of x is 1, so that's 4. And the derivative of 2 is constant, so that's 0. And we can just leave that off. For f of x equals 2x to the 3rd minus 5x to the negative 1. Even though it's negative, you can still use the same rules. All right? The 3 times the 2 will give us 6x, power down to 2, 6x squared. Negative 1 times negative 5 will give us positive 5. And then the negative 1 will power down because it's negative. We're going the other way. We can negative 2. So when f of x equals 2x to the 3rd minus 5x to the negative 1, f prime of x equals 6x squared plus 5x to the negative 2. Find the derivatives of each function. All right, the first one, f of x equals negative 2. Well, that's a constant. What is the derivative of a constant? F prime of x equals 0. G of x equals 3x minus 1. What is the slope of the tangent line for 3x minus 1? The slope is constant, it never changes, so here we'll say g prime of x equals 3. And finally, y equals t squared plus 2t minus 3. We're going to call this one dy dt because they aren't using x as the variable, they're using t. It's the same thing. The t squared power, excuse me, use the power rule, plus 2t, the derivative of 2t is 2, and the derivative of negative 3 is a constant, so we leave it alone. So in conclusion, the 4 rules we talked about were the constant rule, which says the derivative of all constants is 0. The power rule, which is if f of x equals x to the n, the derivative would be n x to the n minus 1. The constant multiple rule, which says if your function is multiplied by a constant, you just take the derivative and multiply the derivative by that constant. And finally, the sum and difference rule, which says if you have a bunch of functions added up, take the derivative of each different function and add those up.